Here we're looking at example 1 from our 2.2 set of notes, but before we dive into that, let's go ahead and look at the definition for the derivative, because it's actually something that we've already gone ahead and discussed. Believe it or not, the derivative is just another word that we use to describe the slope of our tangent line for a particular function at a particular point. So again, back from 2.1, number 2 set of notes, we were looking at all these tangent slopes at a particular target value, and that's pretty much what this notation is saying. We're taking the derivative of a function at this particular point A. And we saw that from our 2.1 notes, it came out to be the limit as h goes towards 0 of f of a plus h minus f of a all over h. So we saw again that extensively in the 2.1 number 2 set of notes. Now, when we're trying to apply that definition to example 1, then we can go ahead and say that the derivative, the limit as h goes towards 0 of, pretty much we're going to go ahead and throw in that distance away from our target x value. So that's why we have 6 plus h minus, and then our y target value. So we have then 3 times 6 minus 1 all over h. Going ahead and distributing onto this guy, we end up then with the limit as h goes to 0 of 18 plus 3h, and this should also have a minus 1, minus 3 times 6 is 18, minus 1 gives us 17, all over h. Simplifying this further, we end up then with the limit as h goes to 0 of 17 plus 3h minus 17, all over h. Which simplifies down to the 17s canceling out with one another. So then we end up with the limit as h goes to 0 of 3h over h. And we can notice that these h's actually end up canceling out, leaving us then with just the limit as h goes to 0 of this constant 3. And as a result, the limit as h goes to 0 of that constant would literally just be that constant. So this limit then comes out to be 3. So again, that is example 1, and using that definition of our derivative from our 2.2 set of notes.